The Tecnotion simulation tool provides simulations based on your application to help you find the most suitable motor for your need. In this tutorial, we'll demonstrate the extensive options of the simulation tool to save time in your development process. We're now on the home page of the simulation tool where you can start your simulations in 3 different ways. The first way is by creating a movement profile, the second way is by entering a Tecnotion product number, and the third way is by choosing a motor from our product list. The most convenient option is the last one, where we select an iron core motor for this simulation. The iron core motor comes in 4 different series. Based on the forces needed in your application, you can make a rough estimation which series would make the best fit. For this demonstration, we choose a motor from the TM series. All available TM motors will be shown on screen. Optionally, you can filter the selection by entering your specifications in the boxes at the top. For this application, we select the TM3S motor, which is the smallest iron core motor available. It also comes with a different winding, the TM3Z, which needs less voltage but draws more current. After the motor is selected, you can insert the application data. This is done by clicking the round grey Application Data button. In the pop-up menu, we need to start by entering the temperature of the heatsink. This value should equal the temperature of the block where the motor is mounted to, or equal the water temperature if water cooling is performed. The thermal resistance indicates how easily the heat flows away from the motor. This parameter depends on the total setup, but the thermal resistance of the motor is already taken into account. When proper cooling is installed, this value will be fairly close to 0 Kelvin per watt, but when the setup lacks cooling, it will be significantly higher. The moving mass should be the mass that needs to be moved excluding the motor mass. The inclination angle is 0 degrees for horizontal applications and 90 degrees for vertical applications. It's also possible to enter intermittent values. The friction force is the total estimated friction applicable to every movement profile. Friction can be caused by bearings, cables, attraction force if applicable, and other components. Finally, the bus voltage should be inserted. You can choose between AC and DC. Now you're set to insert the first movement profile. The first option is a trapezoidal point-to-point movement, which is the most common profile. The second option is a sinusoidal point-to-point movement, which is smoother. The third constant velocity trapezoidal and fourth constant velocity sinusoidal profiles are equal to the first 2, but are using other input parameters. The acceleration ramps are useful when you don't have a point-to-point movement, but are not necessary in most applications. Constant velocity and standstill are also common, and oscillation can also be selected as point-to-point profile. The movement profiles are repeating indefinitely, so these options are needed when the motor stands still at any point. For the trapezoidal point-to-point movement that we've chosen, the moving distance is the first parameter necessary to enter. Then also the needed moving time and the acceleration time should be inserted. The max VDI volts is a parameter that limits the jerk in the application, but it's not necessary to adjust this. Finally, additional friction can be inserted under load in newtons. This value will only be used in this specific movement profile. Create the profile by clicking on the orange button. In the results table, we can see immediately that the selected TM3S motor is too small for the inserted application. This is indicated by the red fields where several physical parameters are too high. Especially the coil temperature should be looked at. When the listed value is higher than the maximum temperature, the motor is likely too small for the application. Let's suppose that after the first movement, there's also some constant velocity movement. This movement can be inserted by clicking the orange plus button under Movement Profiles. We take 1 second movement and no additional load. We now have 2 movements, but we add a third one. This is a standstill of 0.5 seconds. It is clearly visible that there are now 3 movements. You can delete a movement by selecting the profile and click Delete Profile. We are now deleting the second one. Only the point-to-point movement and the standstill are remaining. To make a movement back to the original starting point, duplicate the first profile, change the order, and add a minus sign in the moving distance. According to the graph, we first move 1.5 meters, then we have a small rest, and then we move back to the starting point. Next to the plotted movement, also other physical properties like velocity and acceleration can be plotted, individually or simultaneously. From the calculated data at the bottom of the screen, we can see that this adjusted application is still too difficult for the selected motor. You can push the blue Change Motor button at the top in order to select another motor in this series or from a different series. We select the TM6S motor, which has 2 times the force of our original TM3S. The orange marked temperature indicates that the temperature is within 20 degrees of the maximum motor temperature, which is acceptable. No other parameters show red or orange warning lights, so this motor is suitable for the application. Now that the simulation is finished, the scenario can be saved via the left menu. Your saved simulation will be stored under the Save Scenarios menu for future reference and use. The scenario can now also be exported to a PDF file or shared with others. To seek help with your simulation or request a quote for our motors, just click these buttons. The displayed units can be changed from SI units to Imperial units in the left menu. The simulation tool also allows to download the manual, CAD drawings or technical specifications from the selected motor. When your application parameters change somewhat after the initial design, this will be no issue for the tool. You can still change any parameter like moving mass and see its direct impact on the physical parameters. The motor now becomes slightly hotter, but it is still acceptable. This scenario can replace the first saved scenario or be saved under a new name. When saved as new scenario, also the second scenario becomes visible under saved scenarios. Also, this new scenario can be exported to a very useful PDF file or be shared. For more information about the simulation tool, contact us or visit our website.